Hello guys, welcome back to my channel Algorithm Avenue. In our previous video, we have entirely discussed about the concept of dropout layers. Now in this video, what we will be doing is, we will be developing two models. Our first model is model without dropout layers and second model is model with dropout layers. Okay. Now after development of the models, we will be considering two datasets. First is regression and second is classification dataset. Okay. Now after considering the datasets, we will be training our models on these datasets and finally we'll be observing the results. Okay, if anyone are watching this video without watching my previous video, I recommend them to please watch my previous video to understand this video efficiently. Okay, first let us consider regression dataset. Okay, I'm importing necessary libraries. First is NumPy, second is Pandas and third is Torch. Okay, I'm considering my randomly generated dataset with 1000 rows of data and 3 input features. Okay, this is my randomly generated dataset, not pre-processed dataset. Okay, after that I'm splitting my data into training and testing. Okay, 80% of the data I'm giving it to training and 20% of the data I'm giving it to testing. Okay, you can see that test size is equal to 0.2. That indicates 20% of the data is going to testing. Okay, after that I'm converting my training and testing data from NumPy to tensors. Okay, I'm doing this conversion because PyTorch framework internally expects tensors. Okay, for internal calculation it expects only tensors, so that is why I'm converting from NumPy to tensors. Okay, after conversion I'm building my model. Okay, this is my model with 5 hidden layers. Okay, in my first hidden layer I have 512 hidden units, whereas in my last hidden layer I have around 256 hidden units. Okay, this is entirely my model, which I named it as overfitting model. Okay, after that I'm considering my loss function, which is mean squared error loss function. Okay, to work efficiently on the regression datasets, we need to take an loss function, that is mean squared error loss function. Okay, after that I have considered optimizer as Adam optimizer. Okay, as it is the best optimizer, I have taken it as Adam optimizer and learning rate as 0.001. Okay, after that I have selected my epochs as 500. Okay, after selection of the epochs, this entire data is this entire code is my training loop and this entire code is my testing loop. Okay, after this I have printed my results. Okay, for every 100 epoch I am printing my results. Okay, that is train loss and test loss. Okay, after 100 epochs of training I have got around 17.6 train loss and 15.8 test loss. Okay, after 500 epochs of training I have got around 0.18, okay, 0.18 train loss and 0.33 test loss. Okay, you can see that there is a huge variation between train loss and test loss. Okay, this variation indicates our model is efficiently learning on the training data but unable to learn on the test data. This indicates our model is overfitting. Okay, our model is clearly overfitting. Now what we will be doing is, we'll be seeing the necessary solutions that we can make in our, that we can change in our model to prevent this overfitting. Out of many solutions to the overfitting, let us discuss an important solution in this video, that is dropout layers. Okay, now let us see how can we actually implement dropout layers in our model. Okay, this is basically my model with dropout layers. Okay, you can see that I have named it as dropout model with arguments as self comma dropout underscore probability. Okay, self and dropout underscore probability are my arguments. Okay, you can name this dropout underscore probability as dropout ratio or dropout as well. Okay, this P indicates my dropout ratio. Okay, this P indicates my dropout ratio, which I have taken it as 0.1. Means out of 512 hidden units, okay, out of 512 hidden units at each epoch training, randomly 10% of the hidden units are dropped. Okay, out of 512 hidden units at every epoch training, 10% of the hidden units are dropped, randomly dropped. Okay, this is meant by dropout ratio. Okay, every time you need to implement dropout layer after each layer activation function. Okay, after each hidden layer activation function you need to implement, or you can implement dropout layer. Okay, you see that after my first hidden layer I have implemented my dropout layer and subsequently for the later layers as well. Okay, this is my dropout model. Now we'll be training our data on the dropout model. Okay, Now my loss function is mean squared error loss function, and optimizer is Adam optimizer, okay, with learning rate around 0.001. Okay, now I have considered 500 epochs as my training. Okay, now this is my entire training loop and this is my entire testing loop. After that, I am printing my model results. For every 100 epoch, I am printing my results of the training loss and test loss. Okay, at the initial stages of training, that is 100 epoch, at the 100th epoch, I am getting 17.6 loss and test loss as 16.43. Okay, now after 500 epochs of training, my training loss has come down to 0.29, whereas test loss has come down to 0.32. Okay, means you can see that there is no much variation between training loss and test loss. Okay, means our model is performing equally on the training data and test data as well. Okay, but you can observe that there is a change between previous model and this model results. Okay, my training loss has increased. Okay, this indicates that we need to either increase the data or increase the number of hidden layers or increase the number of hidden units or increase the number of epochs. Okay, so after increasing those hyperparameters, we can decrease the training loss and decrease the test loss as well. Okay, in this way we implement dropout layers in our model for the regression dataset. Okay, now in the next section of the video we'll be seeing it for classification dataset. Now let us implement dropout layers for the classification dataset. Okay, for that I'm importing dataset, that is make blobs dataset from ScikitLearn.dataset. I have already have a built-in dataset, that is make blobs dataset. Okay, I'm importing that dataset and I'm storing my features in x1 and storing my target variable in y1. Okay, x1 is my features and y1 is my target variable with 100 samples. Okay, means number of rows are 100 and number of features is 1. Okay, this is my entire data. Okay, now I'm splitting my data into training and testing. Okay, 90% of the data I am giving it to training and 10% of the data I am giving it to testing. Okay, I have less number of samples, so that is why I have increased the number of training samples than the test samples. Okay, now I have done the conversion from NumPy to tensors. Okay, after that I have built a model, that is overfitting model class. Okay, I have named it as overfitting model class with around 5 hidden layers. Okay, with around 5 hidden layers, and at the initial hidden layer I have around 1024 hidden units, and at my final hidden layer I have around 512 hidden units. Okay, this is my overfitting model. Okay, now I have considered BCE with logits loss, that is binary cross entropy loss, because my problem statement is binary classification, so that is why I have taken binary cross entropy loss function. Okay, now I have taken my optimizer as Adam optimizer with learning rate 0.1. Okay, this is my accuracy function. Okay, after that I have taken 100 epochs as training, and this is my entire training loop and this is my entire test loop. Okay, now say I am printing my model results. Okay, for every epoch I am printing my training accuracy and test accuracy. Okay, at the initial stages of training I have got around 68% training accuracy and test accuracy as 60%. Now when you go at the further training, you can see that I have got around 98% as my training accuracy and 60% as my test accuracy. You can see that my test accuracy is fluctuating from 100 to 60. Okay, so this clearly indicates that there is no consistency in the test accuracy. So this in turn indicates we are overfitting. Okay, our model is overfitting with good performance on the training data and poor performance on the test data. Now we need to find a solution to this problem, that is dropout layers. Now let us make few changes in our model so that I can overcome this overfitting. Okay, for that I have just considered dropout layers. Okay, just I am implementing dropout layers between two hidden layers to solve this overfitting problem. Okay, you can see that this is my first hidden layer and this is my second hidden layer. In between these both hidden layers I am implementing dropout layer. Okay, I am considering dropout ratio P is equal to 0.01. Okay, my dropout ratio is 0.01. Okay, I have considered very much less dropout ratio because I have few training samples, right? I have few training samples and test samples. So on this small data set, I need to train a bigger model. Okay, so in this bigger model, if I drop more and more neurons, so this may cause underfitting. So that is why what I have decided is to keep the dropout ratio as small as possible. Okay, now I have considered same 100 epochs, and this entire is my training loop, and this entire is my testing loop, and I'm printing my model results. Okay, now at the initial stages of the training, I've got around 51% training accuracy and 40% test accuracy. Now as you go on training the model, at the 100th epoch, I have got around 48% training accuracy and 40% test accuracy. You can see that it is clearly underfitting. Okay, this problem can be solved by increasing the amount of data and much decreasing the dropout ratio and increasing the number of hidden units and hidden layers in my model. Okay, now but you can see that when you compare the both training and test accuracy, we can clearly observe that there is no overfitting. Okay, we have solved the problem of overfitting, but we are just underfitting. Okay, now to solve this underfitting, we need to take more data and more deeper model. Okay, this is the solution, and this is how we have implemented dropout layers in our model with respect to classification dataset. Okay, now let us see few tips so that we can efficiently implement dropout layers in our model. Okay, among them our first step is overfitting, increase the dropout ratio. Okay, in case after implementation of the dropout layers, even you are facing overfitting, then increase the dropout ratio. Okay, if at 0.3 dropout ratio, if you are facing overfitting, then increase it to 0.4 or 0.5. Okay, at the 0.5 you will definitely face no overfitting. Okay, now our second tip is underfitting, decrease dropout ratio. Okay, in case at 0.4 dropout ratio, if you're underfitting, okay, if your training accuracy is low, if your test accuracy is low, then you need to decrease your dropout ratio. Okay, to 0.4, 0.3, 0.2, 0.1. Okay, in this way, by decreasing the dropout ratio, you can prevent underfitting. Okay, our third tip is initially implement dropout at last hidden layers. Okay, now while implementing the dropout layers, first you need to maintain an order. Okay, first implement at the final hidden layer and then subsequently in the later hidden layers. Okay, you need to follow a path from output layer to input layer. Okay, initially implement dropout layer at the final hidden layer and then observe the results, and then still you are facing overfitting, then implement in the before layer. Okay, in this way you need to implement dropout layers in your model. Okay, now our fourth tip is when it comes to convolution neural network, the best dropout ratio is between 0.4 to 0.5. Okay, the ratio from 0.4 to 0.5 gives the best results for convolution neural networks. Okay, whereas for recurrent neural networks it is from 0.2 to 0.3, and whereas for artificial neural networks, okay, that is our case, it is from 0.1 to 0.5. Okay, more than that or less than that may cause overfitting or underfitting. Okay, this is the entire video on dropout layers. Okay, I'll be providing the entire code in the description so that you can make test on it to observe the results. Okay, hope you like this video. If you like the video, please like, share and subscribe.